Alright, this is the circuit that will determine the type of metal that the metal detector detects. And I've got it run off of this frequency generator with two different outputs of the exact same frequency at the same amplitude. They're both running at 15 kilohertz. Both channels are running at 15 kilohertz, the same frequency. Now they go into, this is a voltage comparator, and all it's doing is converting the AC sine wave into a DC square wave pulse. And that goes into the phase comparator chip. Now the phase comparator chip compares the two phases, the phase difference of the two pulses, but it outputs a frequency. Its output is a frequency with a duty cycle that is the difference of the two phases. So measuring that duty cycle is a pain in the ass. So I've used an Opamp with and it's essentially made a two-stage first order low pass filter. And what that does is it takes the duty cycle output of the phase comparator, which represents the phase difference in duty cycle, and it takes that duty cycle representation and just converts that to a voltage output. So the more voltage this puts out, the farther apart the phases are. So the closer to the same the phases are, the lower the voltage is going to be. So it's a voltage representation of the difference of the two phases that start over here. Then I just got a simple analog read of that voltage on my microcontroller. Let's see if I can see this. So that number is showing the voltage being read. Now while I'm going to show that number, if I adjust this little thing here, it adjusts the phase of just this one channel. So I'm going to adjust the phase of the channel. The frequencies are going to stay the same. They're 15 kilohertz, exactly the same. And I'm only going to adjust the phase right here while we watch the voltage being read from the output. So I'm going to see, I don't have a reference to go on, but I'm just going to turn it. And you can see that the voltage is changing as the phase changes, as I adjust this phase on the signal generator. If I can get the screwdriver in it. Alright, so let's go back the other way. Alright, I can't get the screwdriver in there. Alright, going back the other way. So now the voltage is going down, which means I'm moving the phases closer to being the same, which means the duty cycle of the phase comparator is getting smaller, which means they're closer together. Alright, so you see how that works. That's working just fine. Now I'll show you. Alright, this is the phase comparator. Now we go down to here. I'm only using one comparator out of this phase comparator, or this whole chip, which has got 3. So this is the phase, this is one of the pulses in, and this is the other pulse in, and this is the output. So you see the duty cycle of this pulse is equal to the phase difference of the 2 pulses being compared, which is pretty simple once you break it down to that. It's just the duty cycle is equal to the phase difference. And then what we're doing with that op amp, we're making 2-stage low pass filter, which basically just converts this duty cycle into a straight up voltage, so it's easier to read, because I couldn't figure out an accurate enough way to read the duty cycle, since this duty cycle output is well, you can see here it's twice as fast as the input frequencies. So you're talking 30,000 hertz, so you got to measure, you're measuring nanoseconds, which is too hard to do. So it's easier just to convert this duty cycle to a voltage that you can easily read. So with this circuit and measuring the phase difference, with the metal detector you get 2 coils. You put your input frequency in, and then you're reading the frequency back from the other coil. So you're reading the amplitude that you receive, but you're also reading the phase difference, because with the really good metal detectors, the phase difference is how you determine what type of metal you're detecting. You can differentiate between silver and gold versus iron and aluminum tabs and stuff like that. You can differentiate between the different metals you're detecting just by the phase difference, because they affect the phase differently. So there's that part of the circuit done. I still got more to do. I found this this website that basically I made my own interpretation of this part. This guy basically breaks down how to do it all. So this is the phase comparating, differentiating between metal part of it, and this part up here is going to be the amplitude detection circuit. That shouldn't be too hard either. And then I got to make an oscillator circuit, which that ain't going to be hard. So this was the hardest part. I had to use some chips I've never messed with before that seemed really complicated at first, but once you learn how to use them, they ain't that bad. So yep, no, I'll eventually get this a very accurate metal detector done, and we'll go from there.